is Hanis Walida, and I am going to explain what is gravimetric analysis. According to Team Chemio Analytic 2019, gravimetry is the analysis of a substance by means of weighing as well the position. A gravimetric method for analysis is usually based on a chemical reactions such as AA plus RR equal AARR, where a molecule of analyte A reacts with R molecules of analyte R. The product is AARR, usually a very slightly soluble substance which can be weighed under conditions, thus after the drying process of which can be heated into other compounds whose composition is known then weighed. So the steps in gravimetry are 1. Dissolving the substance. The solution must be clear and homogeneous. 2nd, precipitate with reagent little by little. 3rd, washing of deposits. And last but not least, weighing of sediment results. Types of gravimetric analysis. There are 4 fundamental types of gravimetric analysis, of which there are 2 common types involving changes in the phase of the analyte to separate it from the rest of the mixture, resulting in a change in mass. So first we have volatilization gravimetry, involves separating components of mixture by heating or chemically decomposing the sample. 2nd, precipitation gravimetry uses a precipitation reaction to separate one or more parts of a solution by incorporating it into a solid. 3rd is electrogravimetry method, used to separate and quantify ions of a substance, usually a metal. And then the last we have thermogravimetric, a method of thermal analysis in which changes in physical and chemical properties of materials are measured as a function of increasing temperature or as a function of time. How does gravimetric analysis applied in food industry? Gravimetric analysis is commonly used in the food industry to determine the composition and quality of food and beverage products. The method works by separating a component of interest from a food sample, converting it into a solid form, and accurately weighing it. In the detection process, a food or beverage sample is first prepared and filtered to remove impurities. A specific reagent is then added to react with the food additive or interest. This reaction produces a precipitate containing the additive. The precipitate is subsequently filtered, washed, dried, and weighed. The mass obtained is used to calculate the concentration of the food additive using stoichiometric relationships. For example, sodium cyclamate, an artificial sweetener, can be detected by reacting it with barium chloride to form barium cyclamate precipitate. By measuring the mass of this precipitate, the amount of sodium cyclamate present in the food or beverage sample can be determined. This helps identify whether the additive level complies with the food safety regulations.
Gravimetric analysis. The process of determination sodium cyclamate in food beverages consists of number 1 is the process. Sodium cyclamate, the sample will react with calcium chloride. The second one is an insoluble calcium cyclamate precipitate will be formed. And number 3 is the precipitate will be filtered, dried, cooled, and weighed. And for the last is from its mass, the amount of sodium cyclamate in the original sample is calculated. The methodology of gravimetry analysis consists of 8 steps. Number 1 is sample preparation. Sample preparation consists of a representative sample of reagents is collected in a known volume to be analyzed. Step 2, which is precipitation. A barium chloride solution will be slowly added while stirring to the beverage sample, then will react with barium ion to form an insoluble precipitate. The excess of calcium chloride solution will be formed to form calcium cyclamate precipitate. Step 3 is digestion. to allow the precipitate to form completely and then digest it to ensure that it is pure and crystalline. The last one, which is filtration. The precipitate will be filtered using a suitable filtration method. For example, in our experiment, we use the filter paper. Step 5 is washing. The precipitate will be washed with a small amount of warm distilled water to remove any adherent impurities without dissolving the precipitate. The sixth step, which is drying and ignition. The precipitate will be dried in an oven at 105 Celsius until constant mass. And number 7, which is wagging. The dried precipitate will be cooled in a desiccator to room temperature to prevent moisture absorption. And for the last one, which is calculation, the amount of sodium cyclamate content will be calculated in the beverage sample based on the precipitate and the stoichiometry of duration. As for the result, the mass of barium cyclamate precipitate is 0.180 gram, and the molar mass of barium is 611 G per mole, and the molar mass of sodium cyclamate will be 201 G per mole. For the further step, we will find the moles of precipitate. Second one is the mole of sodium cyclamate, and the mass of sodium cyclamate, and the last one is the percentage of mass sodium cyclamate in beverages. The chemical question for our experiment is 2C6H12NHSO3 Na plus BaCl2 equal to BaCCH12NHSO3 SO3 plus 2 NaCl. The moles of precipitate will be 0.000294 mole, and the mass of our sodium cyclamate will be 0.000588 mole, which is 0.11 gram. And the mole of sodium cyclamate will be 0.00058 mole, and the percentage of our cyclamate in beverage will be 65.5%. In conclusion, gravimetric analysis is effective and reliable for determining sodium cyclamate in food and beverage. Many studies found excessive levels in drinks sold at roadside stalls and are regulated under markets. The data obtained can aid in quality control in food industry and vital for ensuring consumer safety. Future studies can be explored comprehensive re-evaluation of its long-term health effect through epidemiological and toxicological research, and also the development of advanced analytical methods for precise monitoring in the food supply. That's all from me.